In this video, we'll discuss the Python dice and craps modules that you can use to do Monte Carlo simulation on a basic craps game, or you could use as the basis for a more sophisticated game that would implement basic craps strategy. So I'm going to assume that you have the basic idea of what's going on, but I'll go through quickly how the process works. First of all, craps is a dice game where you roll a pair of dice sequentially, and based on the outcome of the roll, you either pass or don't pass. We'll talk about those details here in just a second, but before we do that, let's take a look at the dice module that we've developed. It's just a basic module that supports rolling either a die or a pair of dice. The dice module that we've developed is very, very simplistic. First of all, there are only two functions that we use. First of all, we use the roll function, which returns the result of a single roll. So I just use the randint function from the random module and just return a random integer between values of 1 and 6. So if we look at that in action, open up Python here, import the dice module, we can simply say dice roll and it returns a roll of a single die. Or if I want multiple rolls, I can simply say something like dice roll for I in range 100. Oops, if I could type here, range 100, and that just gives me 100 random rolls of a single die. So again, the single roll is a very simplistic function that just returns this random value between 1 and 6. More importantly, for our craps game, because we roll a pair of dice, there's a roll pair function which basically calls the roll function twice and then returns a list that contains 3 elements. It contains the first roll, the second roll, and then the sum, which is the value of the roll. So if we look at roll pair, dice roll pair, you can see that we return these 3 values, and so in this case the first 5 represents the first roll, the second 5 or the roll of the first die, the second 5 is the roll of the second die, and then the 10 is the overall roll. So if we want to roll a 3 and a 4 and a 7 as a second example, we can do the same thing if we want to have multiple values. So we can say something like dice roll pair, for I in range 100. And so this gives me 100 rolls of a pair of dice. And so we have the individual rolls. Like if we look at this one right here, for example, the roll of die 1 is a 3, the roll of die 2 is a 6, and so the overall roll is a 9. If we want to just extract the values, the value of the roll, so in other words, if we're not interested in the individual die rolls, we can simply extract those values. And so one way to do that would be the following comprehension. If we do something like R2 for R in, and then we have an internal comprehension, dice roll pair for I in range 100. And so what we have is we have an internal comprehension that says dice roll pair for, oops, this needs to be an I, not an in, for I in range 100, which is essentially what we just did right here. And then we have an outer comprehension that says, okay, for each one of these values, I'm just really interested in that second value. And so there we see 100 rolls of pairs of dice. Of course, we can do any number here. If we want 1,000, now we have 1,000 random rolls of a pair of dice. So you can see that the dice module makes it very easy to sample either a single roll or sample a roll of a pair of dice. So now that we know how to roll a pair of dice, let's get back to our problem at hand, which is simulating a craps game. So here we see the craps table, and again the basic idea is you should throw the dice sequentially. The algorithm that we use to play craps, we can see right here. We basically roll the dice, and again the outcome is going to be either a 2 through 12, as we see up here. We can use our roll pair function and look at that second value of the list. If the roll's a 7 or 11, it's a pass. Otherwise, if it's a 2, 3, or 12, it's a don't pass. And so we're interested again in this pass or don't pass outcome. If it's not either an immediate pass or don't pass, then we enter into this loop of the game where we establish the point, where a point is the value of a non-winning or non-losing come-out roll. So we've established the point, and then we continue to roll the dice until we either get the point, in which case we pass, or we get a 7, in which case we don't pass. And so the outcome of the turn, the outcome of the roll, outcome of the turn, not an individual roll, is either pass or don't pass. We can either pass immediately, we can don't pass immediately, or we can go through this loop where we continue to roll. At some point we're going to end either by passing, hitting the point again, or not passing by hitting a 7. So let's have a look at the craps module, which is based directly on this algorithm. Go back to our editor here, jump into the craps module, and you can see that the craps module, we define something called a turn, which does one turn at craps and returns the results. And so it's a very straightforward process. Basically, in our turn, we keep track of all the individual rolls so that we can see what those values were at the end. So I define a list where I want to store the individual rolls. I need to keep track of the current roll number so that I can evaluate whether we've passed or don't pass. So we're going to start out with a 0 with 1. Then I'm going to roll the dice. And so I set up, I append to my rolls list, so it's empty here. So this is going to be the first element, or the 0th element. And I just simply do the D, because I've imported the dice module as D. So I say D.roll pair, and then I peel off that second value of the list. Remember that the roll pair returns 3 values, roll 1, roll 2, and then the sum, and we're really only interested in that sum. So we've done the initial roll, and we need to check to see if we passed immediately. So we check to see whether it's a 7 or an 11. If we do, the outcome is 1. 1 stands for pass, 0 stands for don't pass. Otherwise, we check to see if we don't pass, which in case it's a 2, a 3, or a 12. If it's neither of these two, then we enter into the loop. We've established the point, so the point is simply equal to the current roll, and then we sequentially roll. So we roll the dice again, and we compare each roll to the point or to 7. When one of those two things happen, we know the outcome. So when we come out of this while loop, then we have the outcome is equal to 1 if the roll equaled the point, otherwise it's 0. We then return that value, and we basically return 3 values in our function. We return the outcome, which is the 0 or 1, pass, don't pass, the length, which is the number of rolls in the turn, and then we return that list of rolls. In its base, in the module, we also defined a default main function, which just simply does one turn and then prints the outcome. So if we jump back here to Python and look at this, we can just simply say craps.py, and there's the outcome of one turn. Let's do a couple more here. And so you can see that in turn 1, we had a pass outcome, and we rolled a 10, an 11, an 8, a 6, an 8, a 3, a 5, a 3, a 5, a 5, and a 10. And so because we rolled the point, we passed. In the second turn, we immediately rolled a 3, so we don't pass on the come out. Same thing with the third run. We rolled that same 3. In the fourth one, we rolled an 11, so we happen to pass. We can also use the module as part of another Python program. So for example, if we just import the dice module, dice craps. Oops, I'm sorry, we don't need to import dice. We need to import craps. And then we say craps turn. And this time, instead of my fancy output here, I just simply return the 3 values, which is the outcome, which is a 0, 1. In this case, it's a 1 for pass. The number of rolls, in this case 1, and then the roll value. So we can try another couple of turns here and see what the return value is. We could also do a comprehension if we want to do a bunch of turns at one time. Craps turn for I in range 100, for example. And now we have 100 random crap games. And if we just sort of pick this one right here, This says 0 means we didn't pass. We had 3 rolls in our turn. We rolled a 6, which is our point, then we rolled a 5, then we rolled a 7. If we grab this one right here, we did pass, so this is a 1 outcome. There were 9 rolls in our turn. We rolled a 4, so in this case our point was 4. We then rolled a 5, an 8, an 8, an 8, a 10, a 5, a 12, and then a 4. Because we rolled our point back, we have the pass outcome. So the craps module provides a very simple single turn where the only outcome of interest was pass or don't pass, and again we can extract all of the individual rolls. We can either use this directly if we want to do, say, a Monte Carlo simulation to determine the pass or don't pass probability. This would be a very simple problem based on the turn function, or we could use this as the basis for a more sophisticated program where we were trying to evaluate some type of betting strategy where we allocate money across the pass line, the don't pass line, or the individual numbers while we're in the point loop here. But again, I will leave that to you for future work.